So in this, we're going to put everything together. We've learned about the sine law, we've learned about the cosine law, we've talked about bearings. So I think we are ready for tackling word problems which involve oblique triangles. I would argue that the approach for these problems is very similar to what you did with right triangles. Just read the question, draw the correct diagram, and then pick the right trig tool. Now in the previous chapter, you would either pick sine ratio, cosine ratio, or tan ratio. But in this chapter, you're going to pick between the sine law and the cosine law. Okay, so for the first question, Anton is standing 60 meters away from one telephone tower and 80 meters from another telephone tower. If he makes an angle of 70 degrees between the two buildings, how far away are the buildings from one another? So take your time, draw yourself a nice picture, but I'm seeing something like this here. So Anton is here, he's 60 meters away from one building, he's 80 meters away from another building, and that is the distance between the two buildings. Let's say that's x. I forgot that they also told me that the angles between the two buildings is 70 degrees. So he makes an angle of 70 degrees between the two buildings, just like that. So that was the hard part. Now we just have to pick the right trig tool and solve for x. Side angle sine, so let's use a cosine law. So x is equal to 60 squared plus 80 squared minus 2 times 60 times 80 times cos 70 degrees. So x is approximately about 81, let's say 82. Okay, 82 meters. So therefore, the two buildings are approximately 82 meters apart. Okay, so example 2 is actually one of my favorite questions for this unit. So a clock has a 13 centimeter minute hand and a 7 centimeter hour hand. How far apart are the tips of the hands at 4:42? So one of the big misconceptions for this question is that students think that the hour hand is still pointing at the 4. The hour hand is most definitely not pointing at the 4. In fact, the hour hand is closer to the 5 than it is to pointing at 4. So let's draw a rough diagram of 4:42. So let's say 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 42. So this is going to be here. And we're pointing around here. Okay, so you're looking for the distance between the tips of the two hands. Okay, so you know that the minute hand is 13 centimeters and the hour hand is 7 centimeters. So you can solve for the distance between the two tips if we know the angle that separates the hour hand and the minute hand. Now that sounds like it's pretty straightforward, but you actually have to do some thinking here. So what I'm going to do is I'm going to think about how far the minute hand rotated, okay, and how far the hour hand rotated relative to it pointing at 12. So the hour, let's do the minute hand. I think the minute hand is a little easier. So let's say this is theta. So the rotation in the minute hand. So the minute hand rotated how many degrees? Well, one full turn is 360 degrees, but the minute hand did not perform one full turn. It only did 42 out of 60. Because it's 42 minutes of the 60 minutes to complete an hour. So 42 over 60 times 360 degrees. That's how much the minute hand has rotated. Now, I'm going to subtract that by how much the hour hand rotated, and that should give me theta. So how much did the hour hand rotate? Well, the hour hand is between 4 and 5. Like I said, it's closer to 5, but it's between 4 and 5. So if it was pointing straight at 4, how far did it rotate? Well, there are 12 numbers. A full circle is 360 degrees, so each number is 30-degree rotation. So if I rotate 4, if I point at 4, that's 4 times 30, which is 120 degrees. Okay, but be careful, it's not pointing at the 4. It's pointing between 4 and 5. So there's more of a rotation than just 120 degrees. So how much more? Well, it's 42 minutes past 4 o'clock. So you have to add 42 over 60 times 30 degrees, because it's not going to complete it's not pointing right at 5, okay? But it's getting closer to 5. In fact, it's 42 over 60 the way there, because you're 42 minutes into the hour, okay? So if it was pointing right at 5, then this would be 60 over 60, right? You've completed the jump to the next number. You're at the next hour. But since it's only 4:42, you haven't made the next hour. But you're getting really close. All right, so let's see. That's 252. Okay, and like I said, once you have theta, you can solve for x relatively easy, because it's side angle sine, cosine law. Before I do this calculation, I'm just going to make sure everything was correct here. Perfect. Okay, so now I'm going to run this calculation. 7 squared plus 13 squared. So the distance is approximately 16.8 centimeters. Okay. So I think the key misconception, once again, is that you cannot assume the hour hand is pointing at a number. But once you overcome that hurdle, it becomes easier. Okay, so one more question here. So to get to Michael's house, Angela leaves her house traveling at 40 kilometers per hour along a road in an easterly direction for 45 minutes. Okay. She then takes a 30-degree right turn onto a second road and travels at 50 kilometers per hour for 30 minutes before arriving at Michael's house. Determine the distance between the two houses. So I believe the hardest part to this question is really just interpreting it and drawing the correct diagram. Okay, so let's see. Leaves the house, traveling at 40 kilometers per hour in an easterly direction. Okay, for 45 minutes. We'll solve for the distance after. So this question, it's a very common mistake, is that students they draw this. They think that a 30-degree right turn looks like this, but unfortunately, that is not a 30-degree turn. That is a 150-degree turn. That's almost like a U-turn, like you're changing directions, right? That is not a 30-degree turn. So please don't draw that as a 30-degree turn. This is what looks like a 30-degree turn. There we go. That's 30 degrees. Okay. So she takes a 30-degree right turn onto a second road, travels 50 kilometers per hour for 30 minutes. So you know what? Let's say D sub 1, D sub 2. And there's Michael's house. Beautiful. Okay. And you want to find the distance between the two houses. Okay, let's call that theta. So theta is supplementary to 30, so I'm sure you already know that theta is 150. Okay, what about D sub 1? D sub 1, that is, what was it, 45 minutes, 45 kilometers per hour. So 45 minutes is 3/4 of an hour. So that's 30 kilometers. And then we're looking at the second distance is 50 kilometers per hour for 30 minutes. So 30 minutes is half an hour. At 50 kilometers per hour, that's 25 kilometers. Okay, so guess what? It's going to be cosine law one more time. Side angle side. Why not? I promise you the homework is not going to be like this. It's going to be a bit more than cosine law. Okay, so let's do it. Let's solve for x. I'm just going to write d sub 1. Alright, I'll punch it in. I'll just do one extra step. So we said 30 squared plus 25 squared minus 2 times 30 times 25 times cosine of 180, not 180, 150. 150. If it was 180 degrees, that would be going in the other direction. Yeah, that would not be good. Actually, wait, sorry. If it was 180 degrees, she didn't turn at all. She's just going straight. Sorry about that. Yeah, if it's 180 degrees, she's going straight ahead. No turn at all. So let's type this in. 30 squared plus 25 squared. So we're looking at about 53.1. So the distance between the two houses is approximately 53.1 kilometers. So I really believe the hardest part to these questions is drawing the right diagram. I think we've had enough practice with the trick tools, so just draw the right diagram and you'll be able to hopefully know which tool to use, and doing the number crunching shouldn't be that bad.